Hi guys, and welcome to this session on Kubernetes by Intellipaat. Today we are looking to answer what is Kubernetes. But before we get into that, please subscribe to our channel to never miss an update from Intellipaat. Now let's talk about today's agenda. We begin today's session by answering why do we need Kubernetes. Then we talk about what Kubernetes actually is along with some of its features. Then we move on and understand how you can install Kubernetes on your system. After that, we'll look at a very simple hands-on on Kubernetes. And finally, we'll wrap today's session up with a very simple quiz, so you can comment your answers below to find out if you have answered correctly. Also guys, we do provide end-to-end training on Kubernetes, so if you are interested, you can check out the course details given in the description below. Now, let's get into the session.
Why do we need Kubernetes? So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys. And this is exactly how our application used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber. Right? So you have features like location services, then you have customer service, notifications, mail, payments, and passenger management. Right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now, earlier, all these features used to be on one server, right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server. Right now, this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base. Right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependencies. So say, for example, tomorrow my passenger management code fails. So that would lead to, all the features will lead to basically failing, reason being all of them are dependent on each other, right? And this was solved by using microservices. Now, what was microservices? In microservices, we basically decided that all the features should have different code base and should be deployed separately. Now, my customer service is deployed separately. It's in a separate code base. My notifications have been deployed separately. It's in a separate code base, and all of them, they interact using JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message which the other service will decrypt, and then it will try to read it, and any response which has generated it is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services. It was only API calls that is using JSON that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service, the customer service module might not require that much of power that is there in one server, right? But still my customer service module is occupying the whole server and I cannot deploy anything over there. So downscaling it became a problem, right?
Just a quick info guys, Intellipaat does provide end-to-end training on Kubernetes. So if you are interested, you can check out the course details given in the description below. Now let's get back into the session.
Upscaling is no issue. You can also upscale it, but upscaling would also cause the same problem. That is, say, your server is able to handle 10 replicas of your customer service uh, module, or say, let's your customer service module is being bombarded with requests, and it peaks your CPU to say around 85 to 90% of its usage. Now what will you do? If you have deployed this application on some cloud, your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the two servers, right? But again, the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now, how did we solve it using Docker? Now, Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all Dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different, and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in my CPU, what I can do is I can probably deploy one more instance of passenger management, or one more container of passenger management, and the request will then be routed between the two. Also, if my passenger management is not working properly, what I can do is I can shut down passenger management, I can deploy one more container on it, and this will not affect the other application or the other features of your application, right? So with microservices, what you get is zero downtime, right? You get a chance to update your application without causing a problem to the other services, and many more, right? So when we got a Dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine? What is the health of a container? Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help, right? Now there are many container orchestration tools, and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today, right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of your feature which is running, it became difficult to monitor it, right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized, or your container has died because of some reason, then in that case it was manually updated, that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers, it helps us scaling containers, it also helps us restarting containers if any of them fails, and this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it because Kubernetes automatically it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. Is if there is a new feature that you have to include in your application, all you have to do is launch a new deployment which will basically have those feature and the number of containers that you want for that to be supported with. You just have to specify the number and Kubernetes will automatically take care how it deploys it in the backend, right?
Just a quick info guys, Intellipaat does provide end-to-end training on Kubernetes. So if you are interested, you can check out the course details given in the description below. Now let's get back into the session.
So managing multiple containers as one single entity became very simple for us after Kubernetes. Resource usage monitoring was also solved by Kubernetes. So with Kubernetes, what you can do is for every container which is running, you can basically define how much of your computer resources it is going to utilize, right? And the moment the container utilizes more resources, what Kubernetes does is it deploys a new container, right? And that is how it basically does resource usage monitoring. Then we have networking. So networking is a fantastic feature in Kubernetes wherein all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of processing with whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere, and they can interact with each other as if they were one whole system, right? It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is just, there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master. Right? So this is how Kubernetes actually works from the outside. There are a lot of ways to install Kubernetes, guys. We are going to discuss all those ways, right? And out of that, we're going to choose one way which is going to be preferable for all of us. So let's go ahead and start with the session, guys. So guys, now Kubernetes is basically, like I said, can be installed in a lot of ways. So you can install it by kubeadm, you can install it by Minikube, you can install it by KOps, or you can also use Kubernetes on GCP. So these are the most popular ways of installing Kubernetes. Of course, you'll also have the option of installing Kubernetes on Azure or other cloud platforms. On AWS, for example, there is also a dedicated service called EKS, which is Elastic Kubernetes Service. So we're not getting into it. Reason being, once you understand what Kubernetes is, it'll be very easy for you to basically understand those aspects of Kubernetes as well. So basically, first we should understand the core of Kubernetes, how we can start working with Kubernetes, and then we can explore the other options as well, which are available on other clouds. Okay. So the first method of installing Kubernetes is kubeadm. Now guys, kubeadm is a method using which we can install Kubernetes on any bare metal server. So it need not have to be on premise, it need not have to be on cloud, on AWS, on or Azure or on GCP. It can be any generic server, right? It could be a server on Google Cloud, it could be a server on Azure, it could be a server on premise. On all the systems, this installation will work, right? It could be a VM also, which is running inside your computer. On that also, this bare metal installation will work, right? So that is kubeadm. The second way is Minikube. Now guys, Minikube is basically a virtualized environment in which you don't have to create any slave nodes or you don't have to create any master node. You just download the Minikube software and it will virtualize an environment of Kubernetes for you, right? It's a great way for basically practicing Kubernetes, but it's not so great if you want to learn Kubernetes in depth as to how it works, what happens if you play around with different components. If you want to get into all those details, then Minikube is not that of a great choice. But yes, if you want to practice Kubernetes commands and everything, then Minikube is going to be helpful for you, because you can basically get started by having installed Minikube on your system, and you don't have to worry about any cloud or any virtual system as such. Okay. Then our next way of installing Kubernetes on AWS is KOps. So guys, KOps is basically shortcut for installing Kubernetes, but it's exclusively only for AWS, right? So if you want to install or want to get started with Kubernetes on AWS, you can use KOps. But the problem with KOps is that by default, it deploys the instances to be of T2.medium or T2.large. I'm not sure, but those instances, they do not fall under the free tier. All right. So because they do not fall under the free tier, it diminishes our perspective of how we want to learn tools, right? So all the tools that we have learned so far will absolutely work on the free tier of AWS. But if you are installing Kubernetes using the KOps way, then in that case, you will not be able to utilize the free tier of AWS. Okay. Then we have our next way of installing it on or having it set up is Kubernetes on GCP, right? Now, like I said, Kubernetes is a product of the Google Cloud or the Google company, right? And Google company also have their own Google Cloud platform. So on that platform, Kubernetes as a service is also available, right? And you don't have to get into all the details of how to install Kubernetes and everything. Everything is set up for you automatically. You can just get started by using or by throwing kubectl commands on your GCP server, and it'll work like a charm. But again, in that sense, it would not be that much beneficial for people who basically want to set up Kubernetes in their company, or they are probably a DevOps architect or a DevOps engineer whose sole responsibility is to manage the life cycle, and he only has to deal with setting up all the tools in his company. So for that kind of a person, it'll be half knowledge, because he will only get to know how to use Kubernetes and he will know how to set up Kubernetes from scratch. Okay, so guys, these were all the ways or all the popular ways of setting up Kubernetes to get started with it. But like I said, we are going to use the kubeadm way, because I guess that will be the most beneficial for all the people, right? Whether it be a person who wants to understand how Kubernetes works from scratch, or a person who is a DevOps engineer and whose job would be to set up the DevOps lifecycle. And also, I guess it will be beneficial for people who only just want to work on Kubernetes, because even then, this knowledge is going to be helpful for you in the future. All right. So let's start with the installation, guys. So what I'll do is I'll jump onto my AWS management console. Let's start from way scratch. We don't even have our instances ready. So what we'll do is we'll click on launch instance, and let's select our OS to be Ubuntu. Okay, and then we'll choose the t2.micro instance. We'll click on configure instance details, and let's launch 2 instances over here. Let's just specify the number 2, and then just move on to security groups and specify a security group which you basically want your instance to have. So in my security group, I have defined all traffic enabled, so that there's no problem between the clusters to or the nodes to interact with each other. What you can do from a security perspective is that maybe both these instances could have different security groups. So what you can do is you can allow all traffic from that particular security group which is going to serve your slave, and all your slaves could basically be a part of that particular security group. Okay, that is a way that you can do. I'm just doing this way because our purpose is to learn DevOps and not get into the AWS details. Okay, so we'll click on review and launch now, and you can review all the details that you have configured over here. And once you've done that, let's click on launch, select the key pair that you have on your system, and click on launch instances, right? So this will basically deploy your instances on AWS, right? So your instances are now getting deployed. Let's tag them as kmaster for Kubernetes master and knode for Kubernetes node. Okay, so our instances are now getting started, guys. So knode is now in a running state, and if I refresh it, I can see both of these are now in the running state. So I'll choose kmaster, I'll choose the IP address, and let's try connecting to this instance first. So we'll click on yes, and this will basically bring us to the login page. So we'll log into this instance. Yes, we are in. All right, so we are on our kmaster. Let's similarly log into our knode as well. So this is the IP address for knode. Let's open a new session on Putty for this, and let's color code it so that we can differentiate between the master and the slave. Okay, so my slave is orange in color, guys, so we'll remember that for our future references. All right, awesome. So we have logged into both our master and on our slave. All right. Now, although you will be having a document in your LMS, but the way I prefer to install Kubernetes is by going to the official documentation. So you just have to type in install kubeadm, and then you will have the official doc over here. Just click on that, and let me walk you through how you can use this particular documentation. Okay. So I've read all of this, so I know what is written everywhere. If you have a setup like mine, wherein you have an Ubuntu OS, right, and you want to install Kubernetes on it, you can straight away jump to installing the components. But before these components, you will have to install Docker, right? So let's install Docker, guys, on both our systems. So as we studied in the architecture that Docker is a common component among the master and the slave. So let's update the machine that we are going to work on first. Sudo apt-get update on master, and similarly on slave as well. Okay, so master is updated. Now let's install Docker on it. Sudo apt-get install docker.io. So Docker is getting installed on this system. Similarly, let's install Docker on our slave as well. So sudo apt-get install docker.io. Okay, so Docker is getting installed on the slave as well. On the master, it is installed. Now, once you've installed Docker, your job is done. Just follow the documentation now. So the first step would be to execute these commands. And these commands, as is mentioned, is for Ubuntu, right? So if you're using some other OS like CentOS, or if you're using a container for Linux, you can use these respective tabs. But I'm using it for Ubuntu. So hence I would use these commands. And all these commands have to be run as sudo, guys. So let's sudo up. And now let's copy these commands. So let's execute the first command. So it's being executed, and let's run it on the slave as well. So let's sudo up on the slave as well. And now let's copy this command and run it. All right. So I guess our master is ready. So let's copy the second command now. On a master, we'll paste this command. It's done. On a slave, we'll paste this command. It's done.
Just a quick info, guys. Intellipaat does provide end-to-end training on Kubernetes. So if you are interested, you can check out the course details given in the description below. Now let's get back into the session.
Now let's move on to a third command, which is all these three files or all these three lines will go along each other. So let's copy these lines, paste it on our master. It's done. Paste it on our slave. It's done. Awesome. Now let's update our machine. So we'll copy this command, run it on the master. So it's getting updated. Similarly, run it on my slave as well. Okay. Awesome. So on my master and on my slave, I have to run all these commands. So once we're done with the update, we'll start by installing Kubernetes. So let's install first it on our master. So it's getting installed over here. Similarly, let's install it on our slave as well. So it's getting installed over here as well. Okay. So once these components are installed, like it's installed on my master successfully, our next step would be to basically initialize Kubernetes. So Kubernetes is now successfully installed on your master and slave. But what do we do with the installation? We'll have to initialize it so that the slave and the master both are connected to each other and there are no issues. Now, in order to initialize the Kubernetes cluster, now you don't have to worry about the slave. The slave would only be once used just to connect to the master. Other than that, all the commands will now run on the master. Okay, this basically step would be only used if you're not using Docker and you're using some other container software. If you're using Docker, you don't have to worry about this, right? The next step is to basically create a cluster, that is initialize a cluster using kubeadm. So click on this, and then this would be the documentation for the second step. Now in our second step, guys, what we have to do is just jump on to initializing your master. Okay, so now we'll be using kubeadm init command to basically initialize our cluster. So I'll type in kubeadm init, and this is my master, guys. Kubeadm init. Next command would be API server advertise address. Copy this. So this basically requires your IP address for master. So you can give the private IP address as well. So we'll give the private IP address, which is this. Let's copy it, paste it here. Once you have the API server advertised address, the next step is to basically have the pod network CIDR. So I told you while we were discussing the architecture, guys, that on Kubernetes basically works on its own network. It has its own network on which it will work. So this network is called the pod network. Okay, and in this particular command that is using pod network CIDR, we basically define the range in which the IP addresses would be allotted for the Kubernetes network to function. So the range that we want to specify is 192.168.0.0. Why? Because the Kubernetes network, when it works, it needs a plugin for that network to get installed, right? Now there are a lot of plugins that you can choose from. So if you go back to our documentation, you can just scroll down and you will see that you have these plugins. So these plugins are basically your network plugins that you can use. So you have plugins like Calico, Canal, Kilium, Flannel, KubeRouter, Romana, ViveNet, Juniper, right? So what I prefer, my preference is Calico. And for Calico to work, the pod network CIDR should be in this range. 192.168.0.0/16, right? So if you want to install Calico as your network plugin, then you would be defining this particular range, and that is why I'm defining this range on my master as well right now. So 192.168.0.0/16. So once you've specified this, guys, just hit enter. And now you will get a warning. Warning would be error in the number of CPU. The number of available CPU is one less than the required 2. So on the Kubernetes master, by default, you need 2 cores for your master to run successfully. But since we are basically just practicing on Kubernetes, what we can do is we can ignore this check. We can ignore this pre-flight check. So we'll type in ignore and then pre-flight errors. Okay, and then you specify the name of the error. So the name of the error is num CPU. Okay, let's copy that. That's it. That's all you have to specify. Let's hit enter now. So as you can see, the process has now started. So basically your Kubernetes is now getting initialized on your master. And once it gets initialized, like you saw in Docker Swarm, the moment it gets initialized, it gives you a token command, which is basically used to connect any node on the network to connect to the master so that it becomes a part of the cluster. Okay. Similarly, you will get a command over here as well when this particular initialization is complete. So what we'll do is we'll just take that particular command and we'll paste it on a slave, which will basically just then connect to our cluster. So let's wait for this command to get completed and then we'll move forward. Alright guys, so our command is now complete. Okay, so this is the token that we have got. So this is the token that we will be basically passing on or executing on my slave so that Kubernetes runs or it connects to my master. Okay, now in order to run this command, just copy it. And now let's go to our slave. This is my slave, guys. Again, because it's a kubeadm command, we'll have to run it in root. Copy the command and let's hit enter. So it says this node has joined the cluster now, and we can see the nodes over here. But right now, for any command that you want to now use on Kubernetes, you will be using kubectl. So kubeadm's work was only till over here to basically set up the cluster for you. Now because the cluster is set up, now the only commands that we will be using is kubectl. Okay, now in order to use kubectl on the normal user, what you have to do is I'll exit it. Now I am on the $prompt. Now if I use kubectl right now, you will get an error. Let's see what that error is. Right, so it says that type the command kubectl get nodes. Correct, so let's type that command kubectl get nodes. If I hit enter now, you will get an error. The connection to the server localhost 8080 was refused. You always get this error when you have not configured your server properly. Now how can you configure your cluster properly? Now you got this kubeadm command, right? When basically your command was successfully executed. So along with that, there were several other instructions which came over here, which we did not read. So what are those instructions? Your Kubernetes master has initialized successfully. So start using your cluster. You need to run the following as a regular user. So you have to run these 3 commands as a regular user, and only then you will be able to work with your clusters. Let's copy these commands. This is the first command, this is the second command, and this is your third command. So let's copy these commands. Awesome. So now, since you have executed all these 3 commands, if you type in kubectl get nodes now, you will get all the 2 nodes which are there on your cluster. But as you can see over right now, the status of these nodes is not ready. The reason for that is that we have not installed the network plugin. So there is no network on my cluster right now. It's just the master and the slave which are connected to each other. Now for installing the network, what I'll do is just take these commands, kubectl apply, copy these and run it on your master. So this is done. Similarly, you'll run this command, run it over here. So it's done. Now your network plugin is getting initialized, and how you can check the status, you can just type in the command kubectl. So everything in Kubernetes which is basically running is running as a pod. What is a pod? We'll discuss that in a little while. For now, if you want to check the status, just type in kubectl get pods and then hyphen all namespaces. Okay, you type in this, hit enter, and now you can check the status over here. As you can see, all the pods are in the status running state, and all of them are running 2 out of 2, 2 out of 2, 1 out of 1, 1 out of 1. Every pod is running. That basically means your cluster is now ready. So if I type in kubectl get nodes now, if I hit enter, you can see that both my nodes, that is this node and this node, is in the ready state. Okay, so they are in the ready state. That means my cluster is now ready to accept commands to deploy applications on it, right? So we'll do that in a little while in our further sessions. For now, let's come back to our slides. Alright guys, so we have successfully installed Kubernetes. We have configured Kubernetes so that it's in its prime state to basically accept any kind of commands, any kind of deployments on it, right? And that was our purpose in this particular session. So thanks a lot for attending today's session, guys. In our next session, before starting to work with Kubernetes, we'll basically understand how the resources, or what are the resources that we are going to define on Kubernetes so as to our application gets up and ready.
Introduction to YAML. So what basically YAML is YAML is abbreviated as YAML ain't a markup language. Now that's a very funny name, whoever thought of it, that we'll name YAML and we'll put full form of Y as YAML itself. So YAML ain't a markup language is the full form of YAML. So it is data serialization language which is designed to be human friendly and works well with programming languages for everyday tasks. So it is a very simple looking file. The only thing you need to take care of while working with YAML file is the indentation, because it takes indentation very seriously. By indentation, I mean the spaces that you provide between the two constraints that you have, or the list form of the objects file. We will be discussing that later in this section itself. So while creating that, just take care of the spaces. I mentioned it now just before starting it, because I make those mistakes all the time and it says that something is missing and it's not properly configuring and something like that. So please take care of the spaces when you are working with the YAML files. Now YAML includes a markup language with important construct to distinguish data-oriented language with document markup language. So the design goals and features of YAML are very straightforward. So YAML data is portable between programming languages. So you can take a YAML file from here to there. It is basically a subset of JSON file. It is mostly used for giving out configurations and information related to configurations and stuff like that. So it is a very portable kind of information that you can pass on between different programming languages. There is a very much ease of the implementation and usage. So it is very easy to type up. It's not that difficult. Only thing is that the spaces thing is very important to make sure of the spaces that you are using. For that, I would recommend you to use something like a Sublime Text or something where you can get the information in properly indented form where your data is going, instead of directly writing inside of, let's say if you use sudo nano and you try to write it inside of your bash terminal. Instead of that, I'd recommend you use Sublime and then copy paste it. I found it to be much better, but something suits some people, something suit the other people, right? Moving forward, it includes data consistent data model. So it has a data model which is very data consistent. So the way you write things is very consistent and you define things in a very particular way, and that's why it is very easily readable. So if you are a human, if I show you a YAML file right away, you'd be able to tell me what is going on inside it, probably, if you know a little bit here and there. So that is how we'll be learning to create a YAML file. Although when you're working with Kubernetes, there are a lot of different things that you need to learn to define a YAML file. We'll discuss that right now itself, and we'll give you a list of things as well, of the versions and stuff like that you need to keep in mind while creating a YAML file. So a different kind of data model works with different kinds of things. So let's say, okay, we'll give you an example, then I'll show you. So YAML is a superset of a JSON file. As I mentioned earlier, this is very similar to the JSON file. So when you're making an API call, what you basically do is you have your configurations in your YAML file. So when it is making that API call, it will convert your YAML file to a JSON file, right? So there are two types of structure inside the YAML that you need to know. First is maps and second is the list. So there are two different kinds of structures that you need to know about, because that is how you define things. There are maps and lists inside of it, right? So when we map a key to a value in YAML, it is termed as map. So if you have a key value pair, like let's say name, Intellipaat, course, Kubernetes. So this kind of thing is called mapping, where you have a key and you have a value. So you map your name as Intellipaat. So when I search for, let's say if I've created this YAML file and I have this as working, so if I just search for the name, it will give me, if I just, instead of writing name, instead of the names of the name section, if I just put Intellipaat, it will work for me. So because you have defined the name as Intellipaat. And then there is a list kind of things. Now list has an arguments inside of it. All of these arguments are started with a simple dash dash between them, and there is a space between the dash, which we have not mentioned here. So there is a kind of a gap between them while creating them. So as you can see an example here, the first is the argument. It asks you to sleep for 1000 seconds, and then you have the second argument, which is the message which you will be giving, which is Kubernetes test. So this is like a list format. So this is very different from the maps format, where you define something with the help of a key value pair. Inside of this, you can have multiple arguments in a list kind of manner, where it is a sequence of objects one after the other that you want to define, right? So that is how you define the list kind of things. So this is a sample YAML file, as you can see, version services, but this is not very helpful. So I will show you a real life deployment file of YAML, which we'll be using in the next module, but I'll show you right away so that you understand how important the YAML files are. So we'll switch to Sublime for a second, and so you can see I have a deployment of an Nginx here. So Nginx is basically something similar to Apache servers or Tomcat if you have used. So it helps you host things on local host for exposure. So Nginx is that. As you can see, this is right here is key value pair, which is a map, right? I've defined a name, a key, and it has a value version 1. So while creating YAML files, you have to define the API version. Some will have apps v1, some will just have v1, some will have apps beta v1. I'll give you a list of things, because not all of these support, like this has the kind deployment. Since this is a deployment, I'm defining this as a deployment. This is under this API version. So when I'm making the call, this API version has this defined inside of it. But not everything has everything inside of it, right? So if I were using, let's say, ingress, or I was creating a kind of a service or a kind of volume or a secret or whatever, this will change accordingly to that. We'll give you a list of things like that. So when you are creating these files, you can find most of them mostly online. You can just search for it. If you're looking for an Nginx deployment or something, you can find most of the YAML files online itself. But when you're creating by yourself, you need to know some rules, and it'll give you some errors also. I'll show you that also. If I just change it to v1 or something, it should give me some errors in that. So here I have metadata. Now inside of metadata, I have defined the name of the application as Nginx deployment. So if I have to call this deployment, I have to use this name, Nginx deployment. It has few labels inside of it. Now labels and specs and everything, spec we have discussed early on, right? So spec is something where you define the ideal condition of what you want your cluster to be in. So the ideal position of this deployment is to have replicas 3. So I should have 3 pods which are running this deployment, which is the Nginx deployment, right? So this Nginx should run in 3 points, which is the 3 replicas in it. So I have a selector which matches the labels of app name as the Nginx. So if I'm looking for the app name, so here the app is the Nginx, then there is the template metadata, and then there is again, I have defined another specification where I have defined the containers and what image it is pulling. So this is pulling the image of Nginx 1.15.4. So 1.15.4, it is pulling that image. You can define different images that you have created in your Docker. So let's say if I had an image named as Intellipaat rocks, so I can put that here, but with its version properly, then it will pull that image inside of that container, right? And the container port is just 80. So this is how we define a deployment or deployment YAML. So this is a YAML. I'll show you how it works also a little bit, but this is just don't take it for like that you don't understand what is going on. I'm just showing you how this YAML works. This is a deployment. We'll be covering deployments in the next future modules where we discuss it in further. This is just how you define a deployment. Now, why I was saying that you can use something like a Sublime text is because of this line. You see this line right here, it contains 2 spaces between it. So every time you have something lining on and two spaces you want, you can do it like that. So while defining a YAML file, you need to put 2 spaces between anything which is defined inside of something. So inside of metadata, I have 2 different things, right? All of these inside the metadata will be separated between 2 spaces. So if I put backspace, this is 1 and 2, right? 1, 2. 2 spaces should be there. Similarly here, this is also inside 2 spaces. Now this is 2 spaces inside of this. So while I'm defining anything inside of anything, it should be separated with 2 spaces. And when you're defining something with like a hyphen, like an argument, then it has to be 1 space. See, 1, that's it, right? So inside of an argument, between a dash and the whatever the argument that you are defining, there should be 1 space. And in the mapping, while you are mapping, you need 2 spaces. in there, and you should keep a space between the key value pair. So here there will be a space. So that is something you need to take care of while defining this. I'll copy this entirely. I'll show you how it works just for the sake of it. So we'll go to our, so here I'll write nano, which is create to open a file. So nano, this is my deployment one. So I'll name it as dp1.yaml, right? Inside of here, I want to paste the details of this particular YAML file. So I'll just copy it. So I'd recommend you to make something like a YAML file right here when you're typing. Just make sure of the spaces. It is very important. Now we'll go to our back here, paste it, and then we'll have a look at it. And then we'll just control X and exit. So we'll look at it once again. So see, the spaces has been made properly. The image is defined, the container post is defined, everything is working. So my YAML file is now created. Now you can just type kubectl create -f, now the name of the file, which is dep1.yaml. Now what I'm expecting here is, since the kind is deployment, it should say that this deployment was created. So let's hit enter and see what happens. And you can see the apps nginx.deployment was created. Now if I do kubectl get pods, now I have a deployment. I should get, since I mentioned 3 replicas here, I should get 3 pods, right? So if I do, see, 3 pods of the same deployment of the nginx deployment are running. Each of these are running. You can use kubectl describe pods to see in further details about the pods. Let's look at it. So you can see in-depth details here of all the pods. Like this is the name, this is the namespace is default. So this inside of default, it has this particular IP and it is a replica set. It is controlled by the replica set and its IP, its true status and everything. You can get all the details inside if you want, using this kubectl get describe pods. So just we'll do it once again, kubectl get pods, just to show you now how this is working, right? So so here the API version was 1 kind of deployment here, and nginx deployment and whatever it is deployed here. Now you can see I've mentioned 3 replicas here. That is the reason why there are 3 different pods running of the same. All of these are the nginx deployments of the same time. All of these have the same image and same everything, just there are 3 different instances of it running. So if I have a load balancer, if I hit the pod named nginx, if I hit the deployment, which is the nginx deployment, I have 3 pods running in it. So when I hit it from the outside, I just hit I want the nginx to work. I want this app to be running. Now inside that app, we have 3 replicas. Now whatever the status of these is, the load will be distributed in a round robin fashion. And whoever is free, the data will be directed to that. That is the job that the replicas do. It helps you balance the load out. You have different replicas which are running constantly. Now, what I want to show you all is, like I was saying you that the API versions, if it is not perfectly defined, that will create a different problem. So what we'll do is we'll create another deployment file, and that should not work. So what we'll do is we'll just change this to v1, okay, and just copy it entirely, and we'll create another nano file. We'll call this, let's say, not working .yaml. This should not be working, right? We'll just paste it. We'll control S to save it, control X to exit. Then we'll create the same kubectl create -f, name of the file, which is not working .yaml. Now this should not work. See, unable to recognize the YAML file, not working YAML, no matches for the kind deployment in v1. So this is the very important part. Let me just this is the no matches for the kind deployment in version 1. So there is no API version named version v1 which has the kind deployment specified in it. So this is very important to match the APIs with the kind and whatever the data inside of it is. If these two are not matching, your deployment will not work, or whatever it is, your service or whatever you are trying to deploy will not work. You need to have proper API versions so that you have a proper kind of thing that is working. Every different thing is defined under certain things. So you have to get that spot on in order to work. That's why the original part was working, because it was apps/v1. If we just nano it, not working.yaml. If I just write again, it was apps/v1, right? Apps/v1 or app/v1. I think it was app. And then we try again to create this file. Okay, it was probably apps. We'll change it to apps. Or we can just check it out from the previous YAML file. Oh, the Nginx deployment already exists. Now, the name of the container. So while creating this deployment, the problem is I have already specified this name, Nginx deployment. So there cannot be two different deployments with the same name, right? So if I call a deployment, if I'm just like, if I type kubectl get deployment, and then I mention the deployment name, which is Nginx deployment. Then I'm specifying a name of a deployment, and it shows me the details of that deployment, that it has 3 different pods which are running inside of it. All of them are up to date and all of them are available, and they have been created 5 minutes 34 seconds ago. The problem with creating not working YAML here is it has the same name. So you cannot have 2 different things being called from the same name, right? If I have 2 different services which have the same name, how will my system know which service to respond to? That is why your YAML file is very important. You have to define everything properly in here. So that's why we made that mistake. Now we'll go back to the nano not working.yaml. We'll just change it a little bit. Instead of Nginx deployment, we'll name it Nginx test, right? You can name it whatever you want here, and then we'll come back here. And now we'll try to deploy this YAML file again. Now you can see this is created. Now if I do kubectl get pods, I will have 6 different pods, right? Kubectl get pods. It will show me 6 different pods. 3 of the type test, because I have 3 replicas here, and 3 of the type Nginx deployment. Now what I can do here is I can change the number of replicas, and the replicas which we'll be creating will be different here. So we'll do that as well. We'll go to nano again. We have to create another one, right? So we'll copy this. We'll just copy this again. We'll create another deployment, and we'll call this just not.yaml because I don't want to type. Not.yaml I've opened. I've copied this here with Control C. I've gone back to my terminal. I've just pasted it in here. Control X, then I'll open it again for better readability. And I have to mention here apps/v1, and the name will be Nginx deployment replica test. So we'll call it Nginx rep, and inside of replicas I'll change the number of replicas to 2. So this should create another deployment which has 2 replicas, right? So it was called not.yaml, right? So we'll just type it right here real quick. Now deployment was created, so we'll just get pods to see. As you can see, now the rep has only 2 replicas, as we defined the replicas 2 in that file, right? If you see the YAML file again for not.yaml, we have replicas as 2. That is the reason why it has 2 replicas here. So you can see how important YAML is while creating anything inside of it. Although we have not learned about deployments and stuff like that here, but I wanted to show you the importance of YAML files so that when I am working in future on different YAML files, you create those YAML files with me. You type those out, even though I would be copy pasting just to save time, because if I type everything and go about it, it will take a lot of time for me to explain and a lot of time for you to watch. You can just see it and start typing so that you get better hands-on on it. Also, you can either just go and copy paste. It's your wish, totally up to you, but I'd recommend you to type it out a couple of times, right? Okay, then. Now we can go back and move on to our next section.
Alright, so before starting the session, I would just like to tell you guys, if you guys have a cluster on Minikube, if you have a cluster on Google Cloud, AWS, anywhere if you have a cluster, all the commands that we're going to run right now are going to run the same. right? Most of you guys must be working on Minikube. What I'll be doing is I am basically working on an installation on AWS, right? So I'm not going to discuss how do we set up the Kubernetes cluster in this session. Probably I'll add a new session for that where I'll discuss different ways you can set up a Kubernetes cluster. In this, I've already set up a cluster. So let me just quickly go to the terminal to start with our hands-on. All right, so our terminal is here. Now over here the cluster is up and running. Now the way you can see that the cluster is up and running is by checking the number of nodes that are joined on the cluster, right? So for that, if I type in kubectl, which is basically kube control, so the kubectl is the command with which you control the whole Kubernetes cluster. So the first thing that I want to see is the number of nodes which are running on my system, right? So the number of nodes running on my cluster are kubectl get nodes, and these are the two clusters which are two systems which are there in my cluster. This is basically my master. So all my applications will be deployed on this. That is my worker node, right? And both of them are in the ready state, right? Now you can also see what all pods are running on your system. To see all the pods which are running on your system, all you have to do is type in kubectl get pods and then hyphen all namespaces. This will basically show you all the pods which are running throughout your cluster, right? And if you want to see where exactly your pod is running, so all you can do is just go again here and type in -o wide, right? So here are all the pods which are running on your cluster, and some of them are running on one node, some of them are running on the other node. Your master is basically 172.31.44.86. So all the 86 IP addresses that you see here are running on the master. So this pod is running on the master and this pod is running on the worker, right? Then you have IP addresses like this, wherein you have 192.168.1.2. All these IP addresses are basically the IP addresses of the container. So like I told you guys, Kubernetes works off their own network, right? So if one container on or one pod of your cluster wants to interact with another pod, they can interact through these IP addresses. But these IP addresses are only valid inside the Kubernetes cluster, right? They are not valid outside. So if you type this IP address in your browser, you will not get anything. So let us try that. So if I go to my browser and I type in Control V, you'll not be able to see anything. Reason being that this is a private IP address, right? This is only visible to the cluster which is basically working over here, right? Now the first thing that we want to do is basically deploy pods. Now we have to create a deployment. Now in order to create a deployment, you have to write a YAML file. Now what is a YAML file? A YAML file is basically a file in which you specify all the specifications of your deployment. For example, I want a deployment which goes by the name of Nginx, right? The specification of this deployment would be that I want 3 replicas which should be running, right? And the containers should have the image Nginx 1.7.9 running on it, and the container should expose the port 80, right? Now this is the deployment that I want to run. Now say I want to change the number of replicas to say 5, right? So I'll specify 5 over here. I'll save and exit this file, that is deploy.yaml. And now in order to create a deployment, all I have to do is kubectl create deployment and then specify this file which is deploy.yaml, hit enter, and now it should create a deployment for me. The reason it didn't create the deployment for me was this. Alright, so kubectl create and then you specify -f space and then deploy.yaml. Now this should correct the error. So let me first clear the screen. So clearing the scene, and now in order to create the deployment, there are two ways of doing it. Either you can specify create deployment and then the name of the deployment, that is nginx say 1, and then the image of the deployment which is nginx :1.7.9, 9. So if I do this, it will create a deployment called nginx1. So like you see, it has created. And now what you can do is you can basically see the pods which are running for your nginx. So since you didn't specify any number of replicas, there's only one pod which is running for this particular resource, right? And it's nginx1. Now let us see how we can create it from a file, that is deploy.yaml. In order to create a deployment from a file, all you have to do is kubectl create and then -f and then specify your file name, which is deploy.yaml. Now if I hit enter, all you have to do is see kubectl get pods, and you can see that there are 4 replicas of nginx running over here, right? It's not 4, it's actually 5 replicas of nginx running over here, right? And now if I go to my deploy.yaml, I can actually see how much of replicas I've specified. So I specified 5 replicas, and hence I have 5 replicas of nginx running over here, right? So these are all pods, and like we discussed in the architecture, so let me quickly go to the architecture. So here is the deployment, and it has the number of pods specified inside it, right? And this is what exactly what we have done. We have created a deployment, we specified the number of replicas, and these are the pods being run for that deployment, right? And all you have to do for deleting all the pods, all you have to do is delete the deployment, and it will delete all the pods which are running inside it, right? For example, I created the nginx1 deployment, so all I have to do is kubectl delete deployment and then specify the name, which is nginx1, right? Hit enter, and now nginx1 has been deleted. So if I do a kubectl get pods, I can see that there is no nginx1 pod running right now. There's only nginx deployments pod which are running, right? So we have deployed a deployment which has number of pods which are running inside it. Now in order to access these pods, now what is running inside these pods? So if you want to see, like I said, where exactly your pods are running, all you have to do is kubectl get. So let me first clear the screen. So kubectl get pods -o wide if you want to see where your pods are exactly running, and your pods are all running on the node, right? So this is the IP address of your master, which is 172.31.44.86, and all your pods are running basically on the client, that is on the worker node, which have the address 172.31.38.140, right? Now you can check if these pods are running as containers on your worker by going over here. This is my worker, right? So if I specify, say, docker ps, I can see that these are all the containers which are running right now, and all these containers are basically the containers which are running inside this pod with the system containers which are running for Kubernetes, right? So my pods are now running on my worker. The next thing that I want to do is being able to access these pods. So if I go to these IP addresses, I'll be able to access these specific pods, right? But only inside the cluster. For example, if I type it in the browser, I'll not be able to see anything. Let's try that. So if I go to my browser and I type this IP address, obviously I can't see anything, right? But if I type the same IP address over here, I'd be able to get what is there inside the pod, which is basically my nginx file, right? So I am able to access the pods on the cluster. Now I want to access it outside. Now for that, what we discussed in our diagram was we need a service. We need a service in order for us to basically interact with the pods. Now let's create a service. Now for creating a service, all you have to do is type in kubectl create service and the type of the service. Now there are 3 or 4 types of services that you can deploy. Right now we have to deploy a service called nodeport. Okay, what all different type of services are there? We're going to discuss this in our coming sessions. Right now, let's just focus on creating a service which is of type nodeport, right? Once you specify the type nodeport, the next thing that you have to do is specify the name of the service. And remember guys, the name of the service should always be the same as that of your deployment, right? So for our case, our deployment's name was nginx. We'll specify that. And now let's go ahead and specify the ports where your service should basically point on, right? So the 80 port of your service should basically point on 80 port of your pods, because when you created the deployment, you specified that 80 port of the pod should be exposed, right? So you specify 80 colon 80. Why 80? Because Nginx works on port 80, right? You specify this, you hit enter, and now your service has been created, right? So to see your service, all you have to do is kubectl get service, you enter, and now you can see that a service has been created, which is of the type node port and is available on this particular port. Okay, so node port basically means that a port will be opened on the master and on basically on the cluster, and using this port you can access your pods, right? So if I copy this port, and now basically what I want to do is go to my master's IP address, which is this, and then open a new tab. Now specify the port, which is 31827 31827. I specify this, and now all I have to do is hit enter. So the moment I hit enter, I can now see my Nginx image, which basically means my service is working correctly. It is basically pointing to my pods. My request is being load balanced among all the pods which are running. So there are basically 5 pods which are running. So my request is being load balanced among these 5 pods. Okay, so now let us check if it's actually the service which is load balancing it. So let us try deleting the service. So kubectl delete service, and then specify the service name, which is Nginx. Hit enter, and now if I go over here and try to enter, I will not be able to access it. So let me just copy this once more and open it in a new tab. So as you can see, now I'm not able to access my cluster, right? So for the first 2 minutes, it was basically accessing my website from the cache, right? What I did was I opened an incognito window, and when I entered the IP address now, it is not able to access the website, right? Similarly, if I do a refresh here, it is still able to access because it is accessing this from the cache of this system, right? That's why it is able to access. But in an incognito window, you can clearly see it is not able to access this service. Okay, now again if I create a service, it will be able to access. So kubectl create service, which is Nginx, and the type of the service is node port, right? And I want this service to be available on port 80, so I specify that. Okay, so it has been created, and if I do a kubectl get service now, I can see that this is the port it is available on. I copy this port number, I paste it over here, and I'm able to access the Nginx service. So it is that simple, guys. Also, like I told you guys that this port is also available throughout the cluster, right? It's not just on the master. So if I copy the node's IP address, which is this, and come back here and basically just change the IP address to the node's IP address, you can still access the service, right? As you can see, you can still access the service. Reason being, this port is available throughout the cluster. Any IP address that is of the master or the node I specify with this port, I'll be able to access the Nginx service. Alright, so guys, this was the hands-on that we had to do today.
So guys, we have reached the quiz section of our session now. So we have one very simple question for you. I'll lay that question down and you can comment your answers down below and we'll reply to you so that you can find out if you have answered correctly. So please do comment down below. So here's your question. So the question is, which of the following flags is used to retrieve resources from all namespaces? Mind you, we are saying all namespaces. We have seen that in this session during the hands-on section, if you remember correctly. So is it A hyphen hyphen all hyphen namespaces? Is it B hyphen all hyphen namespaces? Is it C hyphen hyphen all hyphen hyphen namespaces? Or is it D, none of these? So whatever you think the correct answer is, please comment it down below to find out if you have answered correctly. Just a quick info guys, Intellipaat does provide end-to-end training on Kubernetes. So if you are interested, you can check out the course details given in the description below. So this brings us to the end of this session. If you have any queries, please leave a comment down below and we'll reach out to you immediately. Thanks for watching guys.